Right, today's lesson is looking at combining dot and box plots. Um, and there's a little bit of theory to put behind this that basically having a dot plot and a box plot is the main piece of analysis of a lot of the work we do with statistics. Um, and part of your writing includes using the pair paragraph writing framework, which you'll be familiar with English. We can also use it in statistics, and it follows along the same sort of ideas that you use in English with having a point, having an explanation, some evidence, and then giving relevance to your answer. So we can see a progression of the different paragraphs that we can use using pair is that we can look at a graph and say that the graph for year 9s is clearly to the right of year 13s. So that's just the point or the most obvious thing that we see in the graph. The next part is looking at some explanation, and we can say that the reason why the year 9s is to the right of the year 13s is because the median of the year 9s is greater than the medians for the year 13s. So you can see at that point that would be a achieved level answer. The next part is then once we've got our explanation is to give some evidence, and we have the median for the year 9s is, and we actually give some values, and then we say that it's 45 minutes higher than the year 13s. So that suddenly gets us further up that level to look at a merit level answer. And R with relevance is to try and give our paragraph some meaning in the overall context that we're dealing with. So you can see that there's an extra paragraph there where we talk about of what the result of knowing that the year 9s is 45 minutes higher than the year 13s means that they get more sleep than the year 13s. Giving that context gives us the excellence level. So it's slightly different from the English model where you, as part of your paragraph, you write a sentence for each part. You just need to have a paragraph that includes all 4 parts. So that bit's really important for getting those higher level answers. So the reason why it's important is that when we're looking at writing a conclusion for our investigation, which we've talked about previously, is called using a statistical inference, where we have a population and then we have our sample. Now, the thing is that we never get to test the whole population because it's a difficult thing to do. People move, things change really quickly. It's much easier to do that to a sample and then get your statistics and imply that about the population. So really looking at the data, it's about looking at our sample and then thinking about what that means about the population. What characteristics can we see in the sample that we could imply are in the population? And that's because whenever you get a sample, it's not going to look exactly like the population. So this GIF that we've got here, where it's showing us different samples that you could take of looking at 30 girls aged 13 and 30 girls aged 14. You can see that even in the different samples, you can kind of see a pattern where we end up with heights being higher for the 14-year-old girls. And that's what's seen in the population. If we saw the population, we wouldn't bother to do a sample. But you can see there that even when we do take a sample, they're never the same. But they can show an overall trend of what the population looks like. So, different things we can look for is that we are looking for where the boxes are in our box and whisker, or where the main body of the dot plot is. So you can see that there is no overlap between those. Okay, then you could have a situation where you have two groups that there is an overlap, but the median of one group is outside the box of another group. And thirdly, we can end up with the overlap where we have the medians inside the box of the box and whisker. Obviously, it's easier to say that there's a clearer difference in this one. Still a difference, but not as big a difference in this group. And then this group is much closer. And what happens is if I took another sample, it's possible that if I took another sample with this group, that I would end up with the opposite thing being true. Because at the moment we've got B is bigger than A, but it's possible I could end up with another sample where I end up with A bigger than B. It's less likely in this one that if I took another sample, it's be unlikely to see a situation like this, or in fact that the medians are reversed. So to also help us make this calculation, we can make what we call the formal inference calculation. It's a little bit complicated to get your head around, but once you do, it's pretty straightforward. Okay, we talk about the difference in the medians, or the DBM, so difference between medians. And then we have the OVS, or the overall visual spread. Now, the overall visual spread is the difference between the lowest lower quartile and the highest upper quartile. Now, it's possible in some situations that the highest upper quartile could be in the same group. So it's not the difference between the different ones. It's just whatever's the highest upper quartile and whatever's the lowest lower quartile, and we subtract those. And to work out whether there's a difference or not, or whether we can be confident there's a difference back in the population, we take the DBM and divide by the OVS. And generally, if it's less than 0.33, we say that the difference is not significant, which means that back in the population, it may not be different. Or we say it's significant, meaning that we're pretty confident no matter what sample we take, we'll always see a difference of the medians in the same way. So what does that look like in our answers? So the first thing we can do is we've got a set of data here with a box plot of A and B. We've got the medians, which we can find the difference of. So 170 take away 152 equals 18. Then we've got the OVS, so the highest upper quartile, take away the lowest lower quartile. So that's 178, take away 143, which gives us 35. Now, if we go through and do the DBM divided by the OVS, which is 18 over 35, which gives us 0.514. which is bigger than 0.3. So 0.514 bigger than 0.33. So therefore significant. Right. So now, how do we describe that, and how do we talk about that in terms of our conclusion? So how confident are we back in the population that we would see group B being higher than group A? So to start off with our pair structure again, so we start with point. From analysing my sample, I see evidence that group B are taller than group A. Okay, and that's because the median of group B is higher than the median of group A. This is because the median of sample B is bigger than the median of sample A. Notice how I refer to the sample rather than the actual population. I can also make the call that B will be greater than the median of group A in the population. I can make this call because the lower quartile for sample B is outside the overlap. So it's outside the overlap of the box. So this median is outside the box of A. The upper quartile for sample A. I can also make this because the proportion of the difference of the sample medians, 18, of the overall visual spread is 0.514, which is significant. This means I'm pretty sure the median population B will be bigger than the median population A if the sampling process was repeated. The shift is greater than what I expect by sample variation alone, so I would expect that most samples from this population would show the same pattern. So we're saying that the difference is so big that it's unlikely if we got another sample it would show us anything different other than B was bigger than A. The median of B is bigger than A. All right. So another scenario, you can kind of see we're slightly more closer together now. So so we can go through that calculation again. So you've got the medians, you've got the lowest lower quartile, which is in A, the highest upper quartile, which is in B. So again, the median of B is higher than the median of A. So from analysing my sample, I have evidence that suggests that group B are taller than group A. This is because the median B is bigger than the median of sample A. I can also make the call that the median of group B will be greater than the median of group A in the population. I can make this call because the median sample B is outside the overlap greater than the upper quartile of sample A. I can also make the call because the proportion of the difference of the medians, which is 11, of the overall visual spread, which is 29, is 0.379, which is significant. I'm pretty sure that the median population of B will be bigger than the median population of A. If the sampling process was repeated, the shift is greater than I'd expect by sample variation alone. I would expect that most samples from this population would show the same pattern. Now, so you'll notice that the language of that's very similar to the previous one, except this time we can't talk about that there's no overlap because the boxes overlap between those 2 points. And you'll see as we go through, we're getting less and less confidence about that sample variation, that if we took another sample, that we'd be able to see the same pattern. The idea of these answers are so that you can in some ways template them. You can replace A and B with the particular, so whether it's gender, whether it's year 9, year 11, whether it's people who play sport, don't play sport, all those sorts of things. So looking at a third scenario, you can see there's much more overlap now. So the medians are much more closer. So there's less evidence to say that one's bigger. We've still got B bigger than A. So from analysing my sample, I have evidence that that suggests that group B are taller than group A. This is because the median sample of B is bigger than the median sample of A. However, there's large overlap, so I'm unsure whether this is the same in the population. The proportion difference of the medians is equal to 7 with an overall visual spread of 18. So when we divide those, we end up with 0.389, which is still significant. So that's the key point. In this scenario, there's so much overlap of the two box plots, or the boxes in the box plots, that we have no more evidence apart from this calculation where we find out that it's more than 0.33. So we can still be confident, but we don't have as much evidence as we had before. I'm pretty sure the median of population B will be bigger than the median of population A if the sampling process was repeated. The shift is greater than what I'd expect by sample variation alone, so I'd expect that most samples from this population would show the same pattern. Okay, so moving along. So you can see now we've got medians which are much, much closer. Right, so the language again changes. So analysing my sample, I'm not sure whether my prediction that group B are taller than group A is correct. we're still getting that the median of B is greater than the median of A, but it's so close that if we took another sample, would it be the same? While the sample median for B is larger than the sample median for group A, there's too much overlap. I'm not prepared to say populations B's median height is bigger. I can't make this call because the proportion of the difference of the sample medians is equal to 2 over the overall visual spread, which is 20, is 0.1. So remember, that's less than 0.33. So what that will mean is that we can't what that'll mean is we can't make that call. It's not significant that there's that difference. And look how that, for the relevance part, this last part, how that changes the last part of the meaning of this. So the shift is less than I'd expect for the sample variation alone, so it'd be possible that most samples from the population would show a different pattern. So what we're saying is that if we took another sample, it would look different. The median population B could still be bigger than, or it could be smaller than, or it could even be the same as the median population A, which is a really important result because it could be that what we have predicted is true. It's just that we can't be confident with just this one sample. Now the question is, what could we do about it? The big way to fix it would be maybe to take another sample, take a bigger sample, or take a number of samples to see if we can get a consistent pattern. Taking one sample may not be enough, but if we doubled the sample size, it would make it more accurate and we would maybe end up with less of a spread of data. So then we may end up with that result being more than 0.33. And the last one is pretty much word for word the same as the previous one. For the conclusion, you'll notice that the values are the same except the difference of 1 for the median, with A being bigger than B for the median. Again, it's not significant, so then we don't see any difference. So how does that work in context with our dot plots? So here we've got a graph with year 11 memory in New Zealand. So this is a sample of male and female. If we just look at the medians straight away, you'll see that the female median is higher than the male. That would suggest that males have a faster reaction time based on this sample. But then how can we be sure that if we took another sample, what would the case be? So we'd have to do our calculation, and you can see we end up with a difference of medians of 4 and a difference of overall visual spread is 23. That gives us 0.17, so not significant. So not significant, so that means that even though this sample shows that the males did the memory test a bit quicker, on average, if we took another sample, we wouldn't be surprised to see it the other way around, or that they were exactly the same or something like that. So going through that list of results we talked about before, we have to think about which one fits this scenario. Something that's not significant, and this is what we came up with. So from analysing my sample, I'm not confident that my prediction that girls have a better memory than boys is correct. This is because the sample median for boys is less than the girls and there is much overlap. So that's the explanation. I'm not prepared to say whether New Zealand, so notice how I've included the population now. So to distinguish between the sample and the population. So New Zealand year 11 girls median is bigger. I can't make this call because the proportion of the difference of the sample medians is -4. and the overall visual spread is 23, which equals 0.1739, which is not significant. So then giving relevance to that, the shift is less than what I'd expect by sample variation alone, so it would be possible that most samples from this population would show a different pattern. The median of the Year 11 girls could be bigger than, could be smaller than, or could even be the same as the median of the New Zealand Year 11s. Key boys. So the key things is identifying when you are talking about the population and when you are talking about the sample. Okay, so here's another set of data that's looking at rugby players by position. So this is their weight, and obviously we're trying to see a difference between forwards and backs. What I want you to do is have a quick go at trying to piece together piece together the conclusion. It might be a good idea to calculate the difference in the medians, the OVS, the overall visual spread, and then try to work out whether it's significant or not. Once you worked out whether it's significant or not, go back and see if you can find the template answer and apply it to this. The population is looking at New Zealand and South Africa rugby players. Okay, so pause the video, give that a crack, see how you get on. Okay, hopefully you gave that a go. And you got that the looking at the proportion of the difference between the medians and the overall visual spread is 20 divided by 31, which is 0.6451, so significant. And the I think it's the first conclusion probably would fit this the best. So from analysing my sample, I have evidence that suggests that the weight of forwards is more than the backs. This is because the sample median for the forwards is bigger than the sample median of the backs. I can also make the call that the median of the forwards will be greater than the median of the backs in South Africa and New Zealand rugby players. I can make this call because the lower quartile of the forwards is outside the upper quartile of the it's greater than the upper quartile of the backs. I can also make the call because the proportion of the difference between the sample medians equal to 20 of the overall visual spread 31 is 0.6451, which is significant. This means I'm pretty sure that the median of the South Africa and New Zealand forwards will be bigger than the median of the South Africa and New Zealand rugby backs. If the sampling process was repeated, the shift is greater than what I'd expect with the sample variation alone, so I would expect that most samples from this population would show the same pattern. Okay. So putting all that together, looking at the data is really important. There's some exercises from your workbook which you need to complete, so go back to your OneNote lesson page.